Alright guys, so today we're doing section 3.2, and the title of 3.2 is Basic Differentiation Rules. Basic Differentiation Rules. And we're also going to talk about rate of change and rate of change. Okay, so basic differentiation rules, and we're going to talk a little bit about rate of change. Today is September the 6th, 2016. Alright, so last class we learned that the definition to find the derivative is that we will use limits, right? And we learned that the definition was that the limit as delta x approach 0 is f of x plus delta x minus f of x all over delta x. If you apply that into the function that you were given and manipulate it algebraically, eventually you would find the derivative, right? Okay. Well, it's very important that you don't forget that, first of all, because the reason why any of these rules work is because of that definition, okay? So don't forget it. Just because I show you all the shortcuts today doesn't mean you can forget the definition of a derivative using limits, okay? Alright, so we're going to just get right to it. Rule number one that you need to learn, it's called the constant rule. And here's what it says. The derivative, remember that means derivative, of a constant, and I'm just going to use letter C, is 0. Always. The derivative of a constant is always going to be 0. Okay? That's rule number one that you need to learn. So I'm going to underline it. You need to learn that rule there. And we'll apply here in just a second. I want to introduce you to another rule real quick, and this is one of the most popular or most powerful in my opinion, okay? And it's called the power rule. Pun intended. Alright, power rule. Here's how it works. It says the derivative of a function in terms of x. Let's say you have a function where you have x to the nth power, okay? Here's how you find the derivative. Notice how you have the nth power, and notice how you have a leading coefficient, in this case of 1. You would take that power and multiply it by the coefficient, so it becomes n times x. And remember how your power was n? Well, it needs to go down by 1, so it becomes n minus 1. Alright, those are the two rules we're going to start with. We're going to apply them. I'm going to show you how to use them, let you practice, and then we'll move on to two more rules. We have quite a few rules to learn today, okay? But these rules you need to be memorized. Honestly, once you practice them, you won't even you'll memorize them without really having to put effort towards it. Yes. No, it's the exact same thing. Good question. dy over dx is the same thing as d over dx. Again, it's just another way to write it, okay? What matters is, notice that both of them are over dx. That means we're dealing with functions in terms of x. Okay, because we could be dealing with functions and not in terms of x, and we're going to get to that. That's called implicit differentiation, and we'll get to it in this chapter later on. Okay? Alright, so we've learned two rules, so we're going to actually practice. So let's try an example. It says, find the derivative of the following. Alright, notice that I am not telling you to use the rules. Notice that I am not telling you to do anything in particular. You can use the definition if you want to, but at this point, honestly, it'll save you a lot more time if you go straight to the rules that we have. Okay, so for number one, you have y equals 7. Example 2, f of x equals x to the third power. Example C, g of x equals the cubic root of x. And example D, let's go h of x equals 1 over x squared. Okay? Alright. Do you guys want to try this on your own before I jump in? Alright, cool. Try it on your own before I jump in, and then we'll discuss some of this. Okay? Alright, let's talk about this. Alright, so for part A, what's the derivative of y equals 7? Okay. Fantastic. Make sure that when you're writing your answer, you're using one of the notations. So, for example, I'm going to say y prime equals 0. Okay? If you just put 0, that 0 on your AP exam could mean nothing, right? They're gonna count points off for you. So you gotta make sure you let them know what you're doing. So you could say y prime equals 0, or dy over dx, or d over dx equals 0. Okay, make sure you are letting them know what you're doing. Okay. Part B, what you guys get? So this comes to the front, right? So this becomes 3x, and then the power goes down by 1, so 3 minus 1 is 2. Cool? Those are simple enough, right? Now this one's got a little trickier, but not really, okay? You have to manipulate them in a way to help you, okay? Did anyone rewrite this first? Yeah, what you rewrite it to be? 1/2, or careful, it's a third root, so 1/3, right? So be careful. Good. You had the right idea though, right? Okay. Now from here, this becomes an easier power rule, right? So we do the exact same thing. We're gonna multiply. So then this becomes g prime of x equals 1/3 x to the, well, what is 1/3 minus 1? Negative 2/3. Okay. At this point, it all depends on what part of the examination you're at. If you're in the multiple choice, they're more than likely not going to leave it like this, okay? But if you were in the free response and they don't ask you to simplify, I would stop there. There's no reason to waste your time. But more than likely, this will be in the multiple choice, and this answer will not be there. So you're going to have to simplify this out, okay? First of all, you need to realize that when you have a negative exponent, that means that you have what? A what? Good. It actually becomes a fractional expression, right? Rational, where that term has to be in the denominator. So this becomes 1 over 3x to the 2/3. And lastly, I don't think that's going to show up either. You need to make sure that you can turn that fractional exponent into some kind of root, which in this case becomes what? The third root of x squared. So your answer is g prime of x equals 1 over 3 times the third root of x squared. Cool? Last one. Did anyone rewrite that? Cool. If we make it x to the negative second power, so then it becomes a lot easier to apply the power rule. So h prime of x becomes negative 2x to the negative 3 power, and that simplifies to be negative 2 over x to the third power. Cool? So as you can see, the rules are there, but you can manipulate the expression in any such way that it can help you apply the rules. Okay, as long as your algebraic manipulation it's correct. Okay? Questions over that? All right, I got one more problem for you, and then we'll move on with another rule. Here's what I want you to do. I want you to find the equation of a tangent line to f of x equals x squared when x equals negative 2. So I need the equation of a tangent line to x squared when x equals negative 2. So I'll give you a couple of minutes to work on that. You can either work on your own or work with a partner. Alright, let's check your answer, and let's compare it to what I did here. Okay, so it's a multi-step process, and you gotta kind of keep tabs on what you're doing. Okay, we know that the equation is x squared, and we know that we have the x coordinate of a point, right? So here's what I did first. So I know that f of x is x squared, so I found the derivative of it. Why would I find the derivative of it? To find the slope. Remember that if you take an equation and you find its slope, it helps you find. If you take its derivative, it helps you find its slope, right? At any point, correct? So by taking the derivative, you should have gotten 2x, right? But since I'm interested at what happens at negative 2, I found out that f prime of negative 2 is negative 4. Therefore, your slope is negative 4, right? So at that point, I had the slope, and then I had the x coordinate. Well, in order for me to find the equation, I need a y-coordinate of that point, correct? So I had to go back to the original equation and plug in negative 2, and I found out that it was 4. So once I did that, I have everything I needed. I have the point negative 2, 4 with a slope of 4. Apply point-slope form, and it simplifies to be negative 4x minus 4. Cool? Questions about that? We okay? Alright, which takes us to our next rule. So the next rule that I need you to learn is called the constant multiple rule. Okay? And let me explain to you what that means. The constant multiple rule. We all know that a constant is just going to be a number right in front of your variable. Agreed? So let's pretend you have, and let me change the color so you can see it better. Let's pretend we have some constant right here being multiplied by some function. The derivative of that would be that same constant multiplied by the derivative of the function. That's all that it means. Okay? So that constant, it's not really going to do anything at the moment. You're going to keep it with it. You're going to keep the constant and multiply by the derivative of the function. Okay? And then I have a whole bunch of examples for you to try, but let's try part A and part B together so that you understand what I'm trying to say. Okay? So look at part A. It says f of x equals 5 times x to the third. So notice how this time I have a constant. According to the rule, so if I'm trying to find a f prime of x, the constant stays. Agreed? And then it says, keep the constant and multiply by the derivative of the function. Well, in this case, the function is x to the third. Agreed? Well, how do you find the derivative of x to the third? Apply what rule? The power rule. So then the 3 comes up front. Agreed? So it becomes 3x squared. Agreed? And then just simplify things out. So then you have 5 times 3x squared, which becomes 15x squared. Do you guys see how you can do this a little faster without having to write this step here in the middle? What's happening? Yes, sir. Pretty much, yeah, that's all we did. What do you mean, like put in parentheses? This right here? Oh, so outside of the derivative? Technically, yeah, you would be correct. I agree. Yeah, there wouldn't be anything wrong because at the end of the day, that constant is just multiplying by the derivative of the function. So yeah, you could rewrite it that way. There's no problem with that. Okay. I want you to notice that this middle step is kind of unnecessary because really what's happening is you're taking that 3 and multiplying it by the leading coefficient because 5 times 3 becomes 15. And then your power is still going down by 1. Okay? Alright, I'll try one more with you guys. This I'm going to rewrite to be 2x to the negative 1. You guys okay with that? So that means that g prime of x becomes what, guys? That times that becomes negative 2x to the what power? And it simplifies to be negative 2 over x squared. Cool? Alright, I want you to try the rest of this on your own. Let me put them in there. So I'll give you a few minutes. You can work on this together or alone. It's up to you. I'll zoom out as much as I possibly can. If you need to come up to the front, that's fine with me. There you go. I want you to try all those on your own, okay? Alright, so here's the answers. Check your answers. Pause the video. Alright, for f. So notice for f you had negative 3x over 2. That's the same thing as rewriting it as negative 3 over 2 times x. Right? So then you have x to the first power, and then that power times negative 3 halves becomes negative 3. And then you have x of 1 minus 1, which is 0, which goes away. Any other questions over this before we move on to our next rule? We good? Alright, so let's move on to our next rule. Rule number 4 So rule number 4, it's called the sum and difference rule. So the sum and difference rule, and here's how it works. So let's pretend you have f of x, and then you have either plus or minus g of x. Okay? So to find the derivative of that, you find the derivative of the first one, and then guess what? You add or subtract the derivative of the second one. Okay? That's really it to it. Okay, so you're going to have, in other words, it doesn't have to be a function, it's just the way that it's written, but if you have like a polynomial, that's really what's happening. If you're having a polynomial with multiple terms being added and subtracted, then find the derivative of each polynomial and then add them or subtract them. That's really all it's saying. Okay? So for example, let's say you have f of x equals x to the third power minus 4x plus 5. Okay? So here's what I mean by the adding and subtracting. Notice how you have multiple terms being added and subtracted. Okay? Find the derivative of each term and then do whatever operation is in between. So if we're going to do f prime of x, what do you guys think it would be? Start with the very first term. So what's the derivative of x to the third power? So it becomes 3x squared minus, what's the derivative of 4x? Just 4, right? Because that x is going to go away. What's the derivative of a constant? Guess what? We're done. That's your derivative. Okay? Alright, so you try the next one. So b, let's say you have g of x equals to negative x to the fourth power over 2 plus 3x to the third power minus 2x. So find the derivative of that and find the derivative of this one as well. Y equals 3x squared minus x plus 1 all over x. Okay? So try those on your own. I'll be walking around to help you out. Alright, check your answers for the previous ones. Sorry, they're up here. Sorry guys. If you're watching the video, pause it. The new rule, you sine and cosine. Derivative of sine is cosine and derivative of cosine is negative sine. And try the following problems. Let's say g of x equals to cosine of x minus pi over 3 sine of x. Alright, so let's do this together since I'm kind of running out on time now. Okay? So to find the derivative of part A, okay, what would you guys do? You have 2 sine of x. So you have there's 2 rules that you can apply here. Which rule and which rule? There is a constant, so you can apply the constant rule. And then you have the derivative, right, of sine and cosine. So what does the constant tell you, right? You have a constant all the way up front, right? And it's being multiplied by the derivative of this. Do you guys remember that one? So that means that it's going to be 2 times the derivative of sine, which is cosine. And that right there will be your answer. Okay. Part B. So if we do g prime of x, take it term by term. Agreed? What's the derivative of cosine? Negative sine. Minus, again, you have a constant times a function, so I'm going to leave that constant there. And what's the derivative of sine? Cosine of x. And it doesn't simplify. You have negative sine of x minus pi over 3 times cosine of x. Okay? These are really not that bad. You're just going to have to memorize that the derivative of sine is cosine and the derivative of cosine is negative sine. Okay? Questions over those before we move on to our last rule that we're talking about today? We're good? Alright, so then last rule is the derivative of the natural exponential function. Which one is that one? The natural exponential function. I'm sorry? Good. So if you have the function of e to the power of x, so the derivative of e to the power of x, guess what? Is e to the x. Okay? So if you have the function e to the x, its derivative would be the exact same thing. Now, for our class purposes, all of this have a way to be proved. Okay? I just want to let you know that there's proofs for all of this, and you're welcome to look at those on your own. We just don't have the time to go over every proof. Okay? Alright. That's another one you're going to have to memorize, so let's try a couple of examples. So let's say you have f of x equals 3e to the power of x. Okay? What would the derivative be? So what would f prime of x be? 3e to the x. Remember that constant just drags along with the... Okay? Let's try another one. So part B, g of x equals to sine x minus e to the x power. What would be g of prime? Cosine x e to the x. Cool? So honestly, the last two rules that we learned, the sine and cosine in the natural exponential function, they're relatively simple. All you gotta do is memorize the derivatives of them. Okay? Any questions about the 6 rules that we learned today before we move on to rates of change? We're cool? Alright, I'm gonna give you a little break since you're falling asleep, and then we'll pick it up with rates of change. Okay? So take a breather. If you need to go to the restroom, go to the restroom. Alright. Last topic of the day will be rates of change. Okay? So, in your own words, what's the rate of change? What? Changing rates? So, like, give me an example.
Like, if you're pouring lead into a bucket, the rate at which lead is going into the bucket.
So, what's being compared, though? What makes it a rate? The speed. So, what is speed? Okay, so we can talk. There you go. So we got a rate of change there. The change in distance over the change in time. Cool. In your case, like the change of the amount of material that you're dropping per time, etc. Okay, good. So rate of change. So guess what? We're gonna be able to use derivatives to deal with rates of change as well. Okay. So some of the examples that we're gonna. First of all, you're also gonna see this word. So they're known as instant, and I think I'm gonna spell this wrong. So whatever, instantaneous. Is that how you spell it? Okay, instantaneous rate of change. So what does the word instantaneous mean? At a specific moment, right? So remember how we were talking about the tangent line, how we were using the secant line to find the slope at a very specific point? Well, it's kind of the same concept as the tangent line, except now we're going to be dealing with some more problems, right? And we're going to be talking about at instantaneous point, like at this point, what is the rate of change, right? Okay. All right. So some of the things you're going to be dealing with is, for example, like population growth, a production rate, and you don't really have to write this down. I'm just letting you know what we're going to be dealing with. Water flow. So like as you're pouring water into a pool, maybe, right? Velocity. So that's a big one, and acceleration. That's just some of the examples of things we're going to be dealing with, okay? Yep. This is kind of an intro to it. A lot of it is going to be in the next unit. Okay? Alright, so we're going to start with something basic, which is motion. Okay? Something very basic. Okay, so we're going to talk about motion. And motion of an object, and we're going to start very basic. We're going to talk about motion of an object in a straight line. Okay? That says line. Whatever line. So we're going to talk about motion of an object in a straight line. Okay? Now, before we get to it, we need to talk about that if you see the plus sign, that means that you're going either up or to the right. And a minus sign means down or left. Okay? So alright, so let's talk about position. You're going to have a position formula. So typically, when we're talking about position and we're talking about a range, we're going to talk about the change in distance over a certain time, right? So we're going to call that change of S over change of T. That stands for change in distance over change in time. Cool. Alright, here's my question to you. Let's go back to talking about change in X over change in Y, right? Do you guys remember slope? Okay. So how can I find change in S? In this case, the change in distance. So if I'm giving you a scenario, how can I find the difference in distance? It's subtraction, right? Do you guys agree there's going to be a difference? So what are you going to subtract? The final position minus what? Your initial position. So let's call it, since we're using a function of t, we're going to say s of t, so it's going to be minus s of t. That's your original position. Agreed? Now, how are you going to know what your final position is? Well, remember how when we were doing limits, if we have t and we add the change in that distance, that's how you're going to get your final position. Agreed? So we can figure out our final position minus our starting position. That's going to give us our difference, right? Our change in distance in this case. Right? Okay. Let's keep that in mind. Let's try an example, and it's going to make more sense when we try it. Okay, so let's pretend we have a biller. I don't know if I'm saying this right. Biller? A ball? Is it billiard or biller? Whatever, the ball that you hit with the cue, okay? It's dropped from 100 feet.
Wow. You should have just said piano.
That's a lot of damage, okay? So we're going to drop this from 100 feet. The height S at time t is given by the following function. S of t equals negative 16t squared plus 100, where S is in feet and t is in seconds. Yeah. Given by S of t equals negative 16t squared plus 100. So we're using feet and we're using seconds, okay? Here's the question. Can you find the average velocity over the following intervals? And I'll do one with you. So let's do over the interval of 1 second and 2 seconds, right? So it's a total of 1 second, okay? Find the average velocity. Okay, what does it mean by average?
Well, instantaneous velocity would be like the tangent line. Average velocity is like overall.
Right, very good. So we're going to have, in this case, we have this interval. So we need to find the average in this case velocity, between 1 and 2 seconds. It doesn't seem like a lot of time, but doesn't mean that the velocity was the same at every tenth of a second. Okay, but we're just gonna find the average. Now, how do you guys suggest I'm gonna find the average of this? Good. If we can find the change in distance and put it over the change in time, we're going to get a good average, right? So we're going to apply that formula that we have there up here. So the change in distance over the change in time. All right, let's start with the easy part. We know the change in time, agreed? Change in time was 1 second. Very good. All right.
Wait. Should we write that out?
I hope you
got that.
Alright, so according to this, you have to start with your change in distance, and we wrote this out. We have to write our final position minus our starting position, agreed? So how are you going to find out your final position? You have to plug in 2. Thankfully, you have this equation, right? So it's going to become negative 16 times 2 to the second power plus 100, right? That's your final position. And then you're going to subtract your starting position, which in this case would be when t equals 1, right? So then that would be negative 16, 1 squared plus 100. Now typically, you would have a calculator for this. I don't know if anyone has one handy. I do. So I'll figure what this is for you. Okay? Alright, so this becomes negative 64 plus 100. This becomes 36 minus, well, 100 minus 16, that's 84, all over 1. Agreed? Alright, so I'm sure you could have done that in your calculator. Just for time's sake, take my word for it. So now at this case, 36 minus 84, so that's going to be negative 48. Yes, 48. The over 1 is really unnecessary at this point, but we're going to need units. We're talking about velocity. What's happening here? What's being compared? What was the top? The top was feet, and we were dividing by time, which in this case is seconds. So what does this answer tell you? What does that negative 48 tell you?
Negative 48 per second traveling less.
Remember that we're dropping the ball. This is going down. Okay, that's what that negative is telling you. Cool? Alright, I'm going to let you try one on your own. And then we got to move on. Find the average velocity on the interval from 1 to 1.1 seconds. Yes. Yes. The height. Yes. Most of the time they're going to provide you with a position function. Okay? There is one function that you can actually memorize, but they're going to provide you with the position function. I think that you have to memorize it for physics, right? You don't for the position function for physics? It's like negative 32 times gravity squared minus, I don't remember, t plus initial height. Yeah, would. So you guys have a formula chart for it? Okay. Alright, we'll try this one. Let me pause this video. I'm just rambling. Alright, so suppose now we're going to find the instantaneous velocity at exactly 1 second. Okay? We're going to use calculus for it. So let's talk about it. This is very similar to the tangent line problem. Okay, so think about that. So we have the position formula, right? We have S of t. Okay. What can you do to the S of t to find the instantaneous velocity? Think about what this unit is about. What can we do to it? If we take its derivative, it's going to give us our velocity, our instantaneous. At any given point. So if we take the derivative of it, we're going to get an equation just like we've been doing it, and you're going to be able to find the velocity at any given time. Okay? Yes. Yes. Okay? So do me a favor, find out the instantaneous velocity at t equals 1 from the previous problem. Just a reminder, s of t was it negative 16 or 16? Negative 16 t squared plus 100. So what would be the instantaneous velocity at t equals 1? What's the first step? What would you do? So the derivative. So what's the derivative of that function? Negative 32t, right? The 100 would go away. So what is the instantaneous velocity at t equals 1? What are you going to do? Plug in 1. So negative 32 times 1. So that means that the instantaneous velocity at t equals 1 is negative 32 what? Feet per second. Then you go backwards and you're getting ahead of yourself. Then we'll use integration. We'll talk about it. We'll get there. Soon. Oh, not anytime soon. Not that soon. Okay. Alright. Questions of how to find instantaneous velocities. We're good? Alright. I have another problem, but I think you guys get the points. There's not really a point for me to actually go over it. So here's your homework for tonight. I'm actually going to write it because it's all messy. Okay. So homework, it's going to be on page 135. And here we go. It's quite a bit, but it's actually very simple. 3, 8, 10, 18, 19, 23, 24, 29, 36, 38, 52, 57, 63, 75, 76. Oh my God, he's still going. 94, 96, and 99. It is a lot of problems, but a lot of these problems are using those rules, so you should be able to answer them very quickly. Okay? The ones towards the end are instantaneous velocities, so make sure if you have questions on those, definitely ask me next time. But the very first part of this is using those first 6 rules that we learned. Okay? Pop quiz next time. It's not really a pop quiz, it's a quiz. Okay?